Hello, my name is Costa, and I'm doing a final project on developing AI for Car Racing V0. So, Car Racing V0 is a simulated game environment where the agent in the game will operate a red racing car and try to navigate it through the environment, try to drive it as fast and as far as it can without crashing into the grass area, which will slow the vehicle down. And as the agent, at each time step, you can make an observation of the environment, which will give you back a 96 by 96 arrays of raw pixels. So, in a way, the agent is seeing the environment like a human would do. They're seeing a picture instead of seeing the speed or any numerical values, numerical properties of the car. So in a way, that makes the problem a lot harder. And after you make the observations, the agent will perform actions. And there are three values in the actions, and the first value signifies how much you want to steal the wheel. And then the second value stands for how much gas the agent is going to give. And the third value signifies how hard the agent is going to press the brake. And the way we're going to solve this problem is to put it under the framework of reinforcement learning, where at each time step, the agent is going to perform some actions, AT, and it's going to receive some observation, OT, and a scalar reward, RT. So that hopefully the agent will be able to understand the consequences of his or her actions to improve its behavior, and hopefully in the future will perform in such a way that maximizes his or her future rewards. And some of the common algorithms include vanilla policy gradient, asynchronous actor-critic, which is commonly known as A2C. What actor-critic algorithm means is that there is an actor part of the algorithm where the agent will form some kind of policy based on the observation, and then after the agent has performed certain action, the critic part of the algorithm will say how good or how bad is the action, and hopefully the actor and the critic will work together to improve the performance of the algorithm. It's a very interesting algorithm that I want to learn. And most importantly, after I tried to learn those two algorithms, I was hoping to learn A3C, which is asynchronous advantage actor critic. Which is basically a distributed version of A2C, and it has been one of the most popular algorithms in the reinforcement learning world, and I definitely want to implement it. And what's the relationship of this project with CS-613? First of all, neural networks and gradient descent are key for the algorithms. We have already learned the gradient descent through our homeworks, and we're going to learn the neural networks later. As you can see here, we have a pseudocode for asynchronous advantage actor critic, and you can see in the pseudocode how they update the weights. And I was hoping to implement this pseudocode to gain a deeper understanding of how to update weights for a deep neural network. Also, the second point is that I want to know how to update weights in a distributed slash asynchronous fashion, which is what this A3C asynchronous advantage actor critic is all about. By using this algorithm, I would be able to leverage a lot of computational power that I have. I could use multi-core machines or put it in the cloud. I think it's a very useful skill to have, and that's something that I want to do a project on.